this electron, then this is empty state, right? Ideally, if you consider this as Kj vector, right? So really hole has what? K minus J. It corresponds to something here, K minus J. So what we don't see that one, we just assume if you move to here, you have a hole here. So that's basically what is the charge of this hole? It's positive, we showed that one, right? This has current coming from plus E, so these are all electrons negative. Then also is velocity. If you consider, how do you calculate the velocity? Velocity is basically E over dk, right? If you do that one, you can see from the negative side your slope is different, right? This one, that means velocity actually doesn't change. So they both have the same velocity. Electrons and holes velocities are same. But the charges, this one has negative charge, this one has positive charge. This one has wave vector Kj, then this one has K vector K minus J, or something like that. That's basically the charge is, so yeah, we'll talk about the charge right here. So charge is, yeah, this is basically the definition of. Now you can see how easy it is, right? Rather than considering all these n-1 state, you consider only one state that has opposite charge and opposite K value, right? So then how about the effective mass of holes? So if you write Newton's second law for the holes, how do you write the Newton's second law? Mass times acceleration equals plus E, right? So for the electron, me times this one equals, we want to find what is the sign of this one. So that is minus E, right? So electron. So now we showed the velocities are equal. The velocities are both the electron and we hold velocities are equal. So that means velocity means using this one, velocity means dE over dk, right? So we know for this side your slope is negative, this side your slope was positive. If you do that one, so just taking the derivative, you can show that has negative. So if you plug in your mass from here, dE over dV over dH, so you get mH equals minus m. So that's another important difference is your holes have now mass mH that is opposite of your electronic mass. So holes have, if you have positive, it depends on, like even electrons in the conduction band, right? So here we have your curvature, certain value. If you get this one, curvature is opposite, right? So that's why your mass, electron effective mass should be opposite. Is this clear? Because dV over dt is basically your the slope, right? So then if you write your equation in electric and magnetic field, how do you write for electrons and hole? For electrons we write total force as minus E plus V cross P, right? For the hole, this should be basically plus, because charge is now plus. So that is the equation of motion for the hole. So you can see this is how we started doing the hole effect, right? When we did that one, we have negative sign here. Now if we have a hole, then the sign will be opposite. So that means if you, for the holes, if you have material, your conduction is dominated by holes, your hole effect can be positive. So metals always, your hole effect is, or hole coefficient or hole voltage, they are all negative for metals, right? Because conduction is controlled by the electrons. But there are certain, especially in the semiconductors, or even some metals like bismuth, zinc, so they have your hole coefficient positive. That means it's mostly governed by these holes. This whole concept is a little bit tricky. The only thing you need to understand is, rather than considering n minus states in the valence band, you just consider only one missing electron, right? So that they have the properties of this K is minus A, this minus J, but velocities are equal. So hole velocity and electron velocities are same. The mass also, they are opposite, right? That's not, or charges also different. This has positive charge or negative charge and feel good. Let me continue for another 15 minutes. So now I want to talk about just two different band structure calculations. One is called the empty lattice bands, and one is the tight bundle model. So I think everybody should know these two. The empty lattice band is very simple. So basically, everybody is familiar with this relationship, right? Ek is same as Ek plus or minus G. So that energy is same as, right, within the first brilliant zone. But we know Ek is given as, what is this value? That is basically K plus or minus G squared. E squared, K squared over 2m. E squared, H squared, 2m times. Is that it? So now what we are going to do is, we are going to assume maybe some simple, maybe BCC structure. So then we can write our G and K. So how do you write G? G vector is basically HKL in terms of its reciprocal space unit vectors, right? So you can write your G as, everybody agree with this one? ABC means reciprocal space unit vectors. Remember how you get ABC from simple ABC, that triple product and so on. So this is HK, right? Is this fine? So now, if I write my A for a simple cubic structure, it can be even any cubic structure. You can write dash 2 pi over A times, this is unit vector, please remember. Remember this one? 2 pi over A. Because if that is constant is A in the real space, the reciprocal space is coming as 2 pi over 8, right? So that means I can write my GKL as H times 2 pi over 8. Is this clear? Okay, now let's write K vector, because this is what we are going to do, right? So E is given by H plus squared over 2m G plus or minus K squared, right? That's what we are going to do. So this one we wrote now as this one. How do you write K? K is basically Kx, Ky, Kc. Then that one also I can write as, but this is something you should not get confused. So I just write it like this. K as 2 pi over 8 times. This is actually Kx value. So I just write as XYC because these are the parameters we are going to use. Really this XYC means these are Kx, Ky, Kc. Because these are the reciprocal space vector, right? So that means K I can write as 2 pi over A times, this is Kx in the unit vector direction. Is this clear for everybody? So now what we have to do is, for this, only thing you have to do is just calculate E for this different kx, ky, kc. Kx, ky, kc. Please remember this x, y, c means, what are those? They cannot be real space, right? They have to be, this x, y, c means really kx, ky, kc. So now also if you look at, just simply, if you look at this band structure, remember our 1, 0, 0 direction like this, 1, 1 direction like this, right? So this is, we call the, or even this one, endpoint. So in the 1, 0, 0 direction is go from 0 to 1. In the 1, 1, 1 direction it goes from 0 to 1.5. Right? So this can go all the way. So that means your x, that this is kx actually. Please remember, these are kx values. They are going from 0 and 1. These are going from only 0.5. So that's it. So now if you calculate your the band structure, so you can see from this gamma point to h point, this is 1, right? 2 pi over a. This is half point. This is also 1. Because x, y, c, the h point in the both directions that can go up to 1. But in the diagonal direction it only goes to n point. This is the reciprocal space. I think this whole thing is now, since you know these two equations that calculate your energies for different, this x, y, c, for different HKL values. That's very simple. So that means this is the equation, right? So this one I can write as, if you take everything out, this is x minus a, this is kx actually, right? So some parameters. So in terms of, because it's not really kx, this kx becomes this x times your that unit vector in that direction, right? This one. These are some parameters. Ideally, I like to write it like kx value, but these are simply. So this is the final equation, right? So now you can draw your the band structure at any direction. So if I look at G is 0, 0, 0, that means what? Your H, K and L are all zeros. So then if you plug in here, so if you look at this one, so here this example is for PCC structure. That means your H plus K plus L is always even, right? That's the condition. So now if you do this one, just put it, yeah. So in the, if you look at the x and y equals 0 plane, so that means your x is 0, sorry, y is 0, c is 0, then only you get h squared. So sorry, h also 1, right? So you get h squared. That means e 0 times x squared. So you know that how to draw that one, right? This is simply parabola. So that means your this one becomes more like a parabola. This is this in the 0, 0, 0 direction, going through origin, right?